Okay, let's start with the first one. Now, I want us to note something, guys. When we have a straight line graph, our y-intercept is always that value over there, the value right at the end. Okay, so if we have y is equal to negative 2x minus 1, that last part of that sum, that is our y-intercept. So when we want to sketch this first graph that we've got, we're going to name this graph 1, can name the second one graph 2. When we want to sketch that graph, we already know that our y-intercept is equal to negative 1. Now, because we've made x 0 to get the y-intercept, the point that we're actually looking for at that particular point is the point 0 and negative 1. That's where we're going on our Cartesian plane for that particular point. Okay, so we're going to go to the y-axis, put a dot at negative 1, 0 and negative 1. There it is. Okay, then for us to find the x-intercept, we need to make y equal to 0. So I'm going to replace y with 0. So 0 equals negative 2x minus 1. And then I'm going to solve for x. I'm going to take negative 1 over the rainbow, or over to, sorry, I say that with my grade 8s. So when we take something over the rainbow, it changes its sign, or it changes its operation pretty much. That's what we call it, over the rainbow. Okay, so I will then have 1 is equal to negative 2x. And then to get x on its own, I will divide both sides by negative 2. Right? So my x-intercept, x will equal negative 1/2. So I need to go to this side over here and put a dot at negative 1 over 2. But this coordinate, remember guys, because it's a coordinate, it's negative 1 over 2 for x, and I made y equal to 0. So if a question ever asks you guys for the coordinates of the intercepts, the coordinates, you always need to include the thing that you've made 0, because otherwise you're just telling us that x is equal to that or y is equal to that. That doesn't count. Okay, now we only need 2 points to sketch, so we're going to use these 2 points we have on the screen to sketch. Sorry guys, I've been super dehydrated today. It's not been a good time. All right, so we're going to do that, and we're going to sketch just like that. Oh, trying to move this and it's not moving. I know why. There we go. All right, and that's how we would sketch that graph. There it is. All right. Okay, I'm just going to, this is -1. Okay, and that's how we sketch the first graph. Now, let's look at the second graph. If we look at the second graph, name this graph 1, you're going to notice that it's not in the original order that you would then find a straight line graph. So we need to get it into the form y is equal to mx plus c. So I know x is on the wrong side. I need to take x and move it over to the other side, right? So I will get y is equal to, x will come over and become negative x plus 8. Okay, so in this case then, my y-intercept for this graph, I'm going to write it in blue. The y-intercept of this graph is going to be positive 8. So my y-intercept is equal to 8. That means that my coordinate of the y-intercept, I made x equal to 0 to find my y-intercept. So my 0 value should be, or my x value should be 0, and my y value should be 8. So that would be somewhere up here. There. That's the point 0 and 8. Right. To find my x-intercept, I need to make y equal to 0. So I'm going to get 0 is equal to negative x plus 8. So I'm going to take 8 over to the other side, and I'm going to get negative 8 equals negative x. Therefore, x will equal to 8 as well. X will also equal 8. So the coordinates of the x-intercept are going to be, my x value will be 8, and we made our y value 0. Okay, so I'm going to go to the side where x is equal to 8. And then I'm going to sketch that line. Yeah, and clearly Teacher Coco isn't that great at sketching because she's already drawing things in the wrong places. Okay, and that's how these 2 lines should look. All right, there we go. I got it. And then I lost it. Okay, there it is. So that point and that point. And that's how we use the dual intercept method. All right. Welcome to Maths Live, everyone. I hope everybody's having a great Wednesday. Give me a number out of 10, 10 being my exams are going wonderfully, and 0 or 1 being your ma'am. I need a vacation. I need a 6-month vacation twice a year kind of vibe. Oh, Desmarie's at a 10. I like that. That's good, Desmarie. I'm glad you're doing okay. Oh, she's almost done. That's why. It's because she's almost done. How's everyone else doing? Mandy says 1. Wikanya, is that 1p or is that 10? Oh, it's a 10. All right. Sanelisa's at a 12. That's lovely, guys. I'm glad everybody's enjoying it. Balisa, why a 6? Tell me why a 6. I want to make sure that we're okay, that we're not panicked and having a tough time trying to trying to get through these exams. Okay, though, to be completely honest, exams are a stressful time. Okay, I'll wait for your answer. But in the meantime, we're going to quickly finish on the 13th plus. Oh, yeah, I know. Yo, guys, Desiree, that's a lot. Valissa also says, okay, business studies. I never took business studies, but everyone in my grade who took business studies was always stressed because there was so much to memorize. The maths era. Oh, cool. Oh, cool. I'm so sorry. I know school does get pretty tough. Yeah, it does. It's all good though. Your essay needs to be perfect. Yes, you must practice how to do your essay before you go into English paper 2. It's very important, and you need to know what kind of essay. So make sure that you know, guys. Mandy, what's up, my darling?
Ma'am, the thing is with business, also economics, all those subjects, it's a lot of notes because also for economics, we had to study chapter 1 to 8, which is like more than 200 pages of notes. That's the same with, oh, ma'am,
With
it's a lot.
economics as well.
And
See,
there's no
guys,
paper
this
one,
is what
paper 2.
there's just one
One
paper.
paper out of 300.
Ooh, la la. No, your school's not right. I don't know what's going on at your school, but somebody needs to come knock.
Yo, they must,
See, guys,
Mario.
this is why I decided to become a maths teacher because I don't like taking notes. I'm not very good at remembering things. Okay, and the only reason I love English is because I love novels and I love Shakespeare. But other than that, can't do it. All right, business is out of 100. Okay, that's reasonable. That's reasonable. That's a 1-hour paper. That's an okay paper. Okay, let's get into today's stuff. Now, I want us to learn something very quickly, because when we get into a test or an exam setting, especially for mathematics, when we talk about functions, your teachers are not going to tell you anything about functions. Okay, they are just going to say f of x is equal to something or g of x is equal to something, and they're going to keep it moving. So all the properties of each of the functions or the graphs that we have, we already need to know. All right, so we're going to go through a quick exercise on the things that we would want to write down. So normally when we're doing our maths paper, we can put our hand up and we can ask for an extra piece of paper. And the things we want to write on this extra piece of paper are the things that are going to help us about each of the graphs that we know. So when we start Monday's lesson, I'm going to start by saying, give me a summary, so that while you wait that we do at the beginning is going to say, give me a summary of linear functions. And today we're also going to be doing quadratic functions. So I'm going to say, give me a summary of linear and quadratic functions. And you need to be able to not look at your book. You're supposed to be able to just look at the word linear functions and give me all of this information. So let's talk about what this information actually is. All right, we're going to start by saying linear functions give us a straight line graph. So we need to know what kind of graph a linear function gives us. It gives us a straight line graph. From that, we must know that f of x is equal to mx plus c. From here, we need to know that the m, what does m stand for again, guys? What does the m here stand for? The what? Good, Balisa, lovely. That's it, Sanaliso. It's the gradient. And I know if I want to calculate for the gradient is equal to y2 minus y1 over x2 minus x1. Okay, that's the gradient. That's the thing we need to replace. We also need to replace c. And we know c is our what? C is the something something. That's it, correct. C is our y-intercept. But remember, guys, when we want to calculate for the y-intercept, we're going to make x equal to 0. All right. We're going to make x equal to 0. If we want to calculate for the x-intercept, we're going to make y equal to 0. All right. Then we need to remember the domain. And we need to remember the range. Okay. The domain of our graph. Sorry guys, I'm panicked. I just need to check. Did I click record? Okay, I did. I just needed to make sure that I was recording. All right. So remember we said that if I have a straight line graph, there is no x value that my straight line graph would not be. So for my domain, I can say x is an element of all real numbers because my graph will go in both directions of x. And for my range for a straight line graph, I can say y is an element of all real numbers. So on Monday, when ma'am says, give me all the information on a linear function, this is the information that ma'am wants. All right, so you've got two options now. You can either quickly jot all of this down. You can either jot all of this down, or you can take a quick screenshot, and then ma'am is going to move on because we're actually going to be talking about quadratic functions today. Okay, give me a thumbs up when you guys are ready. Thank you, Bikan, just giving me a thumbs up. Everyone else, are we ready? Lovely, lovely, lovely. Thank you, guys. Awesome. All right, let's get started on today's lesson. So today we're going to be learning about a quadratic function. Okay, now the defining quality of a quadratic is the fact that it is squared, that there's always an x squared or a variable squared. Okay, so let's see what we actually get if we try and sketch the graph of this. Let's start with these points. These are the points that we're going to plot on our Cartesian plane. I'm going to go to -1 and -2. Remember, the origin of my Cartesian plane, that is the point 0, 0. And then I'm going to go to 1, and I'm going to go to 2, just like that. All right. Now, I'm going to go in here, and I'm going to replace x with -2. So if my x is -2, my y value is going to equal -2 all squared. What does that give me? -2 all squared will give us, it's not going to be negative, remember, suddenly, so a -2 all squared means -2 times -2. That should give us +4. Are you seeing what ma'am is saying? Okay, so we should get +4. Our graph should be over here. All right, excellent. Okay, let's talk about, oh, by the way, the coordinate then would be my x value -2 and my y value 4. That's what we'd get. Let's talk about when x is equal to -1. If x is equal to -1, y is going to equal to -1 all squared, which is equal to +1, right? So my coordinate at -1 would be -1, or at x is equal to -1 would be -1 and 1. So at x is -1, y will equal +1. We'll be here. Okay, let's talk about when x is equal to 0. When x is equal to 0, y is equal to 0 squared, which is just 0. So the point for x and y are both going to be 0. They're going to fall right there onto the origin, 0 and 0. Okay. Then we want when x is equal to 1, y is going to equal to 1 squared. 1 squared is just 1. So my next coordinate will be at 1 and 1. 1 and 1 would be over here. Right. Then we'll do the last one. If x is equal to 2, y is equal to 2 all squared, which is equal to positive 4. So this coordinate will then be 2 and 4. X is 2 on the side, y is 4 on the side. So that's the point that we will get. Right. So if we sketch our graph, it will look like that. And please don't quote ma'am on this, because technically, guys, I'm not an art teacher. I'm a maths teacher. And my drawing skills prove that I'm actually a maths teacher and not an art teacher. So no judgment, guys, no judgment. There we go. All right. Okay. And this graph is called a what? What graph do we know this to be called? It's called a what? It's not a quadratic. I'll give you guys a hint. It starts with a P. Para something something. Who knows? That's it, Melissa. Absolutely. It's called a parabola. Yes, correct. It's called a parabola. Okay, that's the one. So we know that it's called a parabola. All right. So if you ever hear your teacher talking about a parabola, if you ever hear your teacher talking about a parabola, they're talking about a quadratic function like that. Okay. Oh, Sanali, so trust me, it's okay. We're gonna figure out how to do these quite easily as we go along. All right. I just need a thumbs up from everyone. Are we all okay with what a quadratic function, aka a parabola, will look like? Are we all okay? Yes. Good. Beautiful. All right, let's look at some different forms of this. Let's look at the form y is equal to negative x squared. What happens when I have a negative outside of my x squared? Now, let's use 3 points. We only really need 3 points, right? We're going to use x is equal to -1, or let's make it -2. X is equal to -2. X is equal to 0, and x is equal to +2. All right, so I want you guys to follow with me. It might get a little bit tricky, so I want us to be alert as ma'am goes through this, because it is going to get a little bit tricky. All right, I just want to make this a little bit smaller so that we're not fighting it. Okay, so if x is equal to -2, my y value will read y is equal to negative, and then only after I've written the negative do I open my brackets. So I'm going to get -2 all squared. So what is my answer going to come out now? I'm going to have -2 all squared. That'll give me +4. That's going to give me -4. Good, Valisa. It's going to give us -4. So my coordinates at that point would be -2 and -4. All right, I'm going to, let me quickly draw -1, -2, 1, 2, and then I'm going to go -1, -2, -3, and -4. Not -3, -4. Yeah, there we go. So we know at the point -2 and -4, these 2 points will meet over there. That's where they meet, at the bottom there. All right, let's do the same with 0. Okay, 0 is nice and easy. If x is equal to 0, y is going to equal to -0 squared. anything 0 to the power of anything or 0 times anything is just going to give us 0. So that point is just going to be 0, 0. So that's going to be our origin. Going to be right down the middle. Now, let's go and do x is equal to 2. I'm going to get y is equal to negative, and then open brackets, 2 squared is equal to, this is also going to give us 2 squared is 4 times negative will give us negative 4. So, sorry, I forgot to write this coordinate 0 and 0, and this coordinate over here will be 2 and negative 4. Right, so that point now is at positive 2 for x and negative 4 for y. There. Okay, so this time when we sketch our graph of the function, okay, we're going to get this. All right, now I want us to do a quick comparison, right? And I want you guys to tell me the difference. Okay, this graph in blue, is the graph of y is equal to negative x squared. And this graph in purple is the graph of y is equal to x squared. What do we notice is the difference here? What are we looking at that is different? Look at that, y is equal to x squared, y is equal to negative x squared. I'll give you guys a hint. When my parabola or when my function is a positive x squared, what does my parabola look like? That's it, Sanity, so beautiful. That's it. When I have positive x squared, my parabola smiles at me. It smiles at me. And when I have negative x squared, my parabola frowns. Do we see that? Right. Now, this value that sits in front of x squared, we will denote it for every single graph that we do. We are going to denote it as a. So it's going to be this value. If you ever see your teacher use the value a, this a, right? So we know that if a is less than 0, what kind of values are less than 0, guys? Less than 0? You can even give me an example. Good, they're negative values. So if this value for a is negative, my graph will frown. And if a is greater than 0, that will give us positive values. My graph will smile at me. All right. We also need to note, guys, that a can never, ever be equal to 0. Otherwise, we won't have a function. Because 0 times anything will just give us 0. So we won't have a function. So a cannot equal 0. Thumbs up. Everybody okay? Are we all good? Lovely. All right. Okay, let us then sketch the graph of y is equal to half x squared. Now, here's what I'm going to do. I'm quickly going to take that purple graph that we drew up there, and I'm going to draw it up here. So I'm going to draw the graph of y is equal to x squared over here as well. Okay, 4, 3, 2, 1. I'm going to draw it in purple. I believe it went like that. Through the point 2, through the point 2 and 4. So we're going to take it this way. Okay, and on the side, negative 2 and 4. So over there. All right, so here's what I want everyone to do. I want you guys to use these three values. If x is equal to negative 2, x is equal to 0, and x is equal to positive 2, I want you guys to put them into here and tell me what we notice about the graph. tell me what we notice about the graph if we try and draw it. Okay, I want us to come to a conclusion. I'm just going to fix this because I feel like it looks ugly. I'm going to start with x is equal to 2. All right, you can unmute to tell me what do we think of the graph, or you can type it in the chat when you tell me what's happened to the graph. Anybody got a conclusion for me yet? Or are we still calculating? All right, I'm going to start sketching mine. Okay, so that will give me 2. Anything times 0 is 0. And that would give me positive 4. Half of positive 4 would give me 2. Right, so again, 0, 0. At the point x equals 2, y is also equal to 2. At the point x is equal to negative 2, y is also equal to 2. Good, thanks, Mika, you're lovely. Right, so let's look at what's happened here. I'm sorry, guys. I really do wish I was an artist, but clearly I do not have a career there. It's a good thing that my degree is in education and not in art. Okay. So let's compare very quickly. I'm going to go fetch that other graph from up top there because we're going to need it. Okay. This one. All right. So the purple graph is the graph of y is equal to x squared. Make it a little smaller. I don't need it that big. And I'll even change the color to be purple. Right. The red graph is the graph of y is equal to half squared. And I'll make that graph red as well so we can see. Okay. So let's talk about the coefficient. What value is right there in front of my x squared? What number is sitting right there? If I just have an x squared on its own, the coefficient in front of x squared is 1. Yes, that's it. Good, it's 1. So the graph of 1x squared compared to the graph of half x squared, what do we notice about the half? The half has made my graph wider. Do we see that it's made my graph wider? So lovely, my darling, I hear you perfectly. So if it's made my graph wider, then that means we need to be careful here. We need to then add in here that if A sits in between 0 and 1. So, I'm writing that in the wrong direction. There we go. If A sits in between 0 and 1, so if A is something like a half, or a third, or a quarter, what does it do to my graph? It makes my graph wider. It opens it up like a bit of a bowl. Okay, thumbs up. Is everybody understanding, ma'am? Are we all good? I'm going to write these in bullet point form. Thank you, Bikan, you're lovely. Let's put these in bullet point form. Okay, first, we know that A cannot equal 0. That's point number 1. Point number 2, if A is in between 0 and 1, then my graph will get wider. Wider graph. Okay, then these two statements still hold. Okay, they still hold. There's one, and there's another. All right. Okay, I want us now, let's go and sketch the graph of y is equal to 3x squared. I'm going to put this one in green. Let's do this one in green, guys. Let's do this one in green. All right, tell me what happens, guys, when we sketch the graph of y is equal to 3x. You can do all of these on the same Cartesian plane. All right, use the same points. Use the exact same points. All right, or maybe for this one, let's use x is equal to 1, x is equal to 0, and x is equal to -1. Let's do that. Right, and tell me what happens to the graph. Okay, lovely, Mandy, thank you. Mandy says for the first one, when x is equal to 1, y is equal to 3, good. Y is equal to 3 times 1 squared, that's just going to give us 3. For the second one, y is equal to 3 times 0 squared, which is just 0. Check that last one again, please, Mandy, for me. Y is going to equal 3 times -1 all squared. What are we going to get there? 3, good. We're going to get those points. Right, so if we plot these on our graph, at x is equal to -1, I have 3. At x is equal to 0, I have 0. And at x is equal to 1, I have 3 again. Right. Yeah. Look at what's happened to my graph now. My graph is a lot skinnier. It's a lot skinnier. Do we see that? Now, if we compare that to this graph, let's compare it to the graph of the original formula that we looked for. If we compare y is equal to x squared with y is equal to 3x squared, what do we notice about the a values? If a is greater than 1, what happens to my graph? My graph becomes skinnier. Are we seeing that? Right, so we're going to add that into what we know about our graph. We're going to say, if A is greater than 1, then my graph gets skinnier, a skinnier graph. I hope we're all taking notes, guys. This stuff is going to come back to bite us in the butt at some point. Okay, I know it is. It's an information overload. I agree. I agree. I want you guys to note, though, that these values also work for your negative values. So your -1, if A is in between -1 and 0, my graph will be wider, except it will be wider and frowning, right? And over here, where we say A is greater than 1, if we say that A is less than -1, My graph will still be skinnier. It's just that it will be frowning. It will look down. All right. Desmarie, I know it's a bit of an information overload, but I just need to check. Are you understanding what ma'am has said? Yes? Is everybody okay? Give me a thumbs up if everyone's okay. Okay, cool. Yes, Mandy.
Ma'am,
Yeah, very
the
true.
examples that
Yes.
the examples that we're doing right now are part of the quadratic thingies, like parabola thingy. Is that what we're doing now? Ma'am, I
Yes.
just want to ask,
Yes. So the
how
quadratic
come,
function gives us a parabola. Yes.
why are we not doing, or like, does the turning point of the graph not count? Or
It does. And we're going to get to the turning point in just a little bit. Okay, but if you notice, look at all of my examples, Mandy. Do you see how all of my examples have a turning point of 0, 0?
yes, ma'am, I do.
So I haven't moved the graph yet. So as soon as I start moving the graph, then we'll start talking about the turning point.
Turning
Okay.
point. Oh, okay. Thank you, ma'am.
Okay. All right. Okay, I'm getting to that. I think Mandy's jumping the gun just a little bit, but we're gonna get there. All right. So here's what I want us to do, guys. We're going to look at this first graph over here. Let's talk about this A value. Remember, this is where the A would be. If we look at this graph here, we know that up or down, this way or that way. Which way are we going? Oh, I'm not sure. Okay, but we'll chat in just a bit and I can move wherever you need me to move. All right. So just hang in there for just up. Okay, she wants up. Okay, is that enough? Take a quick screenshot and then we've got to keep moving. Okay, ready? Oh, you want the sketch. Okay, there we go.
Thank you, ma'am.
All right, thank you, my darling, lovely. Okay, if we look at what we've been given over here, what do we know that this 2 is going to do? This 2 sits in the place of A. What's going to happen to this graph? Is it going to be a skinny graph or a wide graph? According to our information, good, Sandy. So it's going to be a skinny graph, right? So from this, we can tell that our graph is going to be skinny. Will it smile or will it frown? It's a positive value, good. So it will smile at us, good. So when we are going to sketch this graph, we know that it must be very skinny compared to our normal graph, and it must smile at us. And if we try to draw it and it doesn't give us that, then we've definitely done something wrong. All right, now let's look at what this +1 does. Let's look at what +1 does to my graph. So we're going to do the exact same thing, guys. Let's use x is equal to -1, x is equal to 0, x is equal to 1. I want you guys to go ahead and give me the points for those. If x is -1, what is y equal to? For each of those, y equals, y equals, y equals. Okay, find me those 3 values, please, guys. When you're ready, you can just pop your answers in the chat and let's see what happens to our graph when we do that. Okay. Okay, I'm going to say y is equal to 2, open brackets, -1, all squared, and then I'm going to add 1 plus 1 equals something. 2, and in brackets, 0 squared plus 1 equals something. 2, open bracket, 1, all squared plus 1. Oh, and maybe check again. For the first one, we're going to get 3, correct. So I'm going to get -1 all squared will just give me 1, right? 1 times 2 is 2, plus 1 is 3, good. So that first one is 3. X is equal to 0, I'm going to get 0 times 2 is just 0, plus 1 is 1. And then over here, no worries. 1 squared is just 1 times 2 is 2, plus 1 is 3. Now, let's look at what's happened. Okay, when x is -1, which is over here, -1, put 1 at 1 as well, right? When x is -1, y is 3. So 2, 3, right? So these graphs are going to meet. Let's use orange for this one. They're going to, those two dots are going to meet there at the point -1, 3. This is going to be the point 0, 1, and this one is going to be 1, 3, right? So look at what's happened now. When my x value is 0, my graph no longer goes through the origin. I don't have 0, 0. I've got 0 and 1. There's my point there, right? When x is equal to 1, y is equal to 3. That would be over here. Right. Okay. So let's talk about what happened. When I add this value, this +1, what did the +1 do to my graph, guys? Normally, if we were drawing the graph, it would go right through the origin. It would be over here. What has that adding 1 done to the graph? Who can tell me? It's shifted it, correct. But it's shifted it in a specific point. Yes, Saneli, so beautiful. It's changed the turning point. But how has it shifted it? Has it shifted it left, right? Up, down? How has it shifted my graph? Ah, correct. And we know that it's shifted my graph up because of that +1, right? So if we look 1 unit up, good, Saneli. So if we look at what we have over here, we know that this part of our graph makes this skinny. It also makes it smile, but this value we've called Q. What does the Q value do to my graph? The Q value will move my graph up or down. We call that a vertical shift. Right? It's a vertical shift. But we need to remember, guys, if Q is greater than 0, which means it's positive, my graph shifts where? Up or down? If it's greater than 0, that means it's positive. My graph will shift up. And if my Q value is less than 0, which means if it's negative, my graph will shift down. Okay. Are we all okay with this? Okay. Happy? Lovely stuff. Good, good, good. All right. So we're not going to sketch the graph of f of x is equal to that. What we're going to do is we're going to interpret it using what we've seen over here. All right. So let's start with the a value. Let's go to the a value over here. We've got -3 in front of my x squared. What does this tell me? Let's talk. Okay. We know that because the value is greater or less than -1, is it going to be a skinny or a wide graph? Skinny or wide, guys? It's definitely not a half or a third or a quarter. It's going to be skinny, Desmarie. Remember, only if it's 1 over something does it become wide. So because this is a 3, my graph is going to become skinny, right? What does the negative part tell us? The negative part tells us that it will what? It will frown. That's it. Correct. It will frown. It must look down. It must look like that. Right. What does the +2 part of it tell us? The +2 part tells us that it shifts down or up. Okay. I agree with Sanalisa and Mandy on this one, Palisa. Because it's a +2, then it will shift up. It's an upward shift by 2. Okay. My graph will shift up. All right. Okay. Shall we interpret the last one? Let's have a look at the last one and let's see what we're going to get. All right, let's think about it. Let's start with our... Okay, that's perfectly fine, my darling. It's okay. All right, so let's start with our A value. Our A value is between 0 and 1. So what kind of graph are we going to get here? Skinny or wide graph? Skinny or wide? Yes, that's correct. A wide graph. It's going to be wide, right? What does the sign tell us? It's positive, right? It's not -1/2. It's +1/2. So that tells us that it will what? Sad or happy face? Smile or frown? It's +1/2, guys. It's not -1/2. Thank you. Lovely. It will smile. Good. It will smile at us. It's a happy face. Right. Now, what does the -3 tell us? -3 tells us that it will shift how? Down. Good. It will shift down by 3. All right. Thumbs up. Is everybody okay with this? Are we all good? Beautiful, beautiful, beautiful. Okay, good stuff. Okay, now remember, this is quite a bit of information to take in. So we need to remember that. Now, I want us to look at something else. Okay, I want us to talk about what every single graph is going to have. So that's good. That's good, Desmarie. So if you need me to like repeat something again, please let me know. Okay, I'm happy to. Okay, let's talk about something. Let's talk about f of x is equal to x squared minus 9. Right. Let's write this example down. Now, ma'am did say that in every single graph that we do, they're going to ask us for the x-intercept and for the y-intercept. But we already know. Let's go back to our summary of, let's go back to our summary of the straight line, the one that we did over here. When we are looking for the x-intercept, we must make y equal to 0. And when we're looking for the y-intercept, we must make x equal to 0. All right, so stick with me, guys. Here's what we're going to see. Right, let's start with the y-intercept. We're going to start with the y-intercept. Y-intercept, I must make x equal to 0. So I'm going to go into this formula. Remember, guys, f of x is also y. This also stands for y. Right, so I'm going to make x equal to 0. So I'm going to get f of x, or I can just replace it with y for now. I'm going to say y is equal to 0 squared minus 9. Right, so that means my y value or my intercept on the y-axis will cut at which point, guys? What point will my graph cut at?
-9.
At -9. Thank you, my darling. Good. My graph will cross the y-axis at -9. We'll do that, -9. Good. That was the y-intercept. Let's talk about the x-intercept. When I want the x-intercept, I need to make y equal to 0. So I'm going to go over here and I'm going to replace y with 0, right? So I'm going to have 0 equals x squared minus 9. But guys, this is a quadratic. It's a quadratic. And if I had to solve for x here, what kind of factorization would we need to use here?
Difference of 2 squares.
It's a difference of 2 squares. Good, my darling. It's a difference of 2 squares or dots, right? So we're going to open up 2 brackets. And I'm going to get x minus 3 and x plus 3. So my two values for x will be x is equal to 3 or x is equal to -3. So my graph will then cross the x-axis at -3 and at +3. All right. So when I sketch my graph will look like this. It will go through that point. It will turn at -9 and it will come up. All right. Now, if we look at what we have over here, this point where my graph turns is called my turning point. Not my turning point, my turning point. What are the coordinates of my turning point, guys? I know that y is the intercept, right? Or -9 is the y-intercept. So that is the y value. What was the x value over here?
0.
What x value did we use? That's it. Beautiful. So my turning point, or the point where my graph turns, is going to be 0 and -9. Let's see if this checks out, right? I know that the value in front of x is actually in front of x squared is 1x squared, right? That tells me that I should have a skinny graph, even though ma'am didn't draw it very skinny. And it should smile at me. And look at that. My graph smiles at me. And this -9 part tells me that my graph should have a shift downward of 9. My graph should shift down 9 units, right? And that's how we went from 0 to -9. And so my graph has shifted down by -9 points. And that point where my graph turns is called the turning point. All right. That's where we're going to stop for today. All right. Give me a thumbs up, guys. Is everybody okay with everything ma'am's explained today? Yes? Lovely, Desmarie. I'm glad you're with me. Thank you, Buikanyo. Beautiful. Nice one, Saneli. So well done. Okay, are we all good? Lovely. Guys, it's quiz night. It's quiz night. Please try and do the quizzes. I'm going to start getting quiz results back up in a little bit. It's just a bit of a hectic time today. Or this past term has just bulldozed me. I've had so much work. So soon we're going to do quiz results, and I'm going to have to look at all your results. And if we haven't done the quiz, then I'm not going to have a quiz result for you. Okay. So there is today's quiz. It is on the linear function, the one that we did linear equations. So f of x is equal to mx plus c. And it's also going to be on the graph that we did today, the one where we did f of x is equal to ax squared plus 2. Okay, okay, Buikanyo saying, ma'am, can I ask in paper 2 maths, which topics exactly do we get? All right, in paper 2 for maths, you get data handling. Okay, so I don't know if they still do it in grade 10, but things like mean, median, mode, all of that range, all of that lovely stuff, that will be in there. Your analytical geometry, in fact, all your geometries will be in here. Your analytical geometry, your Euclidean geometry will be in here. Your trig will also be in here. Trigonometry will also be in paper 2. All right. I feel like I'm forgetting something, but I will remember and I'll put it up. That's okay. It comes much later in the year. Okay, almost at the end of the year, Palisa. Don't stress about it. All right, peeps.